In this video, we continue where we left off in our exploration of the complex relationship between time, motion, and timelessness. Our focus will revolve around the concept of the extended moment, and we will present an assessment of the timeless nature of the photon within the framework of relativity physics. We will also establish the relationships between quantum consciousness, quantum potential, and the concept of timelessness. One of the fundamental arguments is the concept of the photon existing outside of time. Special relativity introduces the concept of light-like intervals, and it is well known that a photon traveling at the speed of light does not experience time or space in the same way that massive particles do. For a photon, passing through space corresponds to not passing through time, creating a state of timelessness. This view provides a counterpoint to our intuitive understanding of time as a flowing continuum. The existence of a photon at the speed of light can be interpreted as a state in which space and time merge into singularities, where the distinctions between temporal and spatial coordinates dissolve. This creates an interesting symmetry between stasis, where time flows through space without any movement, and the speed of light, where space is traversed without any passage of time. In traditional terms, causality operates in the framework of time. Future events cannot affect past ones. However, from the perspective of timelessness, where the linear progression of time ceases to exist, the concept of causality can become absurd or even reversible. How would timeless entities like photons perceive the universe if they could be said to have a form of experience? For example, would a photon perceive the universe as frozen, as has been suggested, in the same way that we perceive it as instantaneously traveling vast distances? While the thought experiment of a photon experiencing time and space is inventive, within the framework of physics, photons have no internal state or consciousness. The timelessness of a photon is well understood in the context of special relativity, but the idea that this timelessness might reflect something more fundamental about the nature of time, such as reverse causality, requires additional theoretical development. As speed increases, one experiences a paradox of perception. Time slows down for the traveler, while the outside world appears to speed up. The traveler in a rapidly moving hot air balloon or relativistic spaceship sees vast swaths of the timescape, but this also leads to a disconnection from it. Interactions with the environment become more superficial. At extreme speeds, like the experience of speeding through a town, one can only see a slice of events in time, missing the deeper rhythms, patterns, and hidden details of the landscape. To truly know something, whether it be a town or a moment in time, one must synchronize with it. If something is at rest, it must remain at rest to observe and understand its structure and nature. Similarly, to fully grasp something in motion, one must attune to its speed and time scale. Thus, the expanded moment provides a greater view of reality, but loses the nuanced intimacy of detailed interaction. While timelessness expands perception, it diminishes the ability to meaningfully interact with events in time, just as moving faster through space-time diminishes the ability to interact with the finer details of the external world. This dynamic reflects the tension between the expanding moment of relative time dilation and the loss of connection to the finer details of the environment. This tension offers profound insights into the paradoxical nature of perception at relative speeds, where time slows down while space expands, and perception becomes increasingly disconnected from direct interaction. At its most basic level, time is characterized by its unidirectional causality, moving from the past to the present to the future. This is the familiar arrow of time that dictates that causes precede effects. However, temporal symmetry offers a different perspective, where the forward and backward directions of time are equally accessible. In this sense, the reverse causality found in temporal symmetry appears as a logical construct, even though it contradicts our everyday experience of the unidirectionality of time. Temporal symmetry, while still rooted in time, represents a more flexible framework that allows access to any point in the temporal sequence, where movement in time can occur both forward and backward. In contrast, timelessness operates beyond time altogether, allowing for leaps between moments without having to traverse every intermediate point. This distinction between temporal symmetry and timelessness is similar to the difference between retracing one's steps, a linear process in time, and recalling a distant memory, a nonlinear process that skips vast periods. Seemingly causal events, such as premonitions of a future event, can result from reverse causality, temporal symmetry, or timelessness. However, because of the limitations of our time-limited perspective, these effects appear identical and indistinguishable. From a broader perspective that includes temporal symmetry or timelessness, premonitions can be understood as an example of reverse causality, information from the future affecting the present, or as a result of timeless information, access to information completely outside the temporal framework. Both mechanisms, reverse causality and timelessness, operate beyond the forward flow of time, but they are indistinguishable from our time-bound perspective. Temporal reversibility and timelessness can provide explanations for quantum phenomena, such as the EPR paradoxes involving quantum entanglement. In such paradoxes, a measurement of one entangled particle appears to instantly affect the other particle, even if they are separated by large distances. This instantaneous effect appears to violate both the speed of light limit and locality, leading to the famous paradox. However, these paradoxes can be better understood if timelessness is taken into account. If photons or other particles exist at the speed of light, they also exist in a state of timelessness. In this case, spatial and temporal distinctions collapse, and this can explain why entangled particles appear to communicate instantaneously. From this perspective, two entangled particles can even be thought of as the same particle when viewed from different points in time and space. In this context, David Bohm's work provides a compelling example of how temporal symmetry and timelessness overlap in the quantum realm, particularly within the context of quantum field theory. In this context, the vacuum state, the lowest energy state of the quantum field, lacks any meaningful concept of time. In the vacuum state, as Bohm describes it, the wave function representing the entire space-time continuum oscillates at such a high frequency that time becomes abstract or virtually non-existent. This state oscillates so smoothly and rapidly that it is beyond time as we understand it. Bohm argues that in this context, time, typically resulting from the regular sequence of changes in physical processes, loses its meaning. The oscillations of the vacuum state occur on such small time scales and at such high frequencies that they approach infinity, making them unobservable and incomprehensible in the conventional time frame. This idea is a powerful example of how temporal symmetry, the possibility of oscillations moving both forward and backward in time, leads to a form of timelessness at quantum scales. At these tiny scales of time and space, energy and frequency tend toward infinity, erasing any meaningful distinction between past, present, and future. In this sense, temporal symmetry can be seen as a form of timelessness that occurs at extremely small scales. While both concepts challenge the unidirectional causality of time, they operate in different ways. Temporal symmetry allows for movement between connected moments in time, but in both directions, forward and backward, while timelessness allows for instantaneous jumps between moments without any transition. However, from our limited perspective in time, these two states, temporal symmetry and timelessness, are difficult to distinguish because they both occur in causal ways. The distinction between temporal symmetry and timelessness is critical in theoretical frameworks, especially as we examine quantum mechanics and the underlying nature of reality. While time, as we experience it, follows a unidirectional progression, Temporal symmetry suggests a deeper symmetry in the laws of physics that allows for reverse causality, and timelessness refers to a state in which time itself becomes meaningless or collapses into something beyond our current understanding. The quantum realm, as Bohm describes it, exemplifies the overlap of temporal symmetry and timelessness. At extremely small scales, the oscillations of the vacuum state become so rapid and uniform that time loses its conventional meaning and moves into a realm where temporal symmetry collapses into timelessness. This reinforces the idea that our conventional understanding of time is limited to macroscopic scales, while at the quantum level, time can behave in ways that are deeply intertwined with timelessness or even engulfed by it. Temporal symmetry therefore provides a bridge between time and timelessness, providing a framework for understanding how the one-way nature of time can be overcome or even dissolved at the smallest scales of the universe. Bohm's concept of implicit and explanatory orders provides a valuable framework for understanding how time and timelessness are interrelated. The explanatory order refers to the explicit, time-bound domain in which events unfold in a linear order. In contrast, the implicit order is the underlying timeless structure in which all events are implicit and interconnected. Bohm's claim that every system must be seen from both sides emphasizes the importance of recognizing how time and timelessness coexist. In Bohm's words, in the time aspect, the becoming of being is grasped, while in the timeless aspect, the being of becoming is grasped. This captures the essence of the tension between time and timelessness. Time represents a process of becoming in which events unfold in order, while timelessness represents a state of being in which all events are already present and interconnected. This duality is echoed in both cosmological models and quantum theories, where the flow of time appears as a relative, emergent property, while timelessness constitutes a deeper substructure of reality. The relationship between time and timelessness is compared to continuous variables in physics, such as position and momentum in the uncertainty principle. In the uncertainty principle, the more precisely you know one variable, position, the less precisely you know the other, momentum. Similarly, the more deeply you participate in time, the less you participate in timelessness, and vice versa. This trade-off is central to the nature of their interactions. A similar dynamic is observed in the context of special relativity. The more space an object occupies per unit of time, i.e., the faster it moves, the less time it experiences relative to a stationary observer. As the speed approaches the speed of light, time slows down for the moving object, effectively reducing its participation in time. This leads to the conclusion that the effect of time diminishes as it moves toward timelessness. Both breadth and depth require time, but they cannot be pursued simultaneously without sacrificing one for the other. Time acts as the substrate that allows both breadth and depth to emerge, but it limits our ability to fully attend to both at the same time. Similarly, the more one interacts with time, the less one can interact with timelessness, highlighting the fundamental tension between these two modes of existence. A profound concept introduced in this chapter is the idea that one must step outside of time into timelessness to access other points in time without traversing the entire series that connects them. This is similar to a mathematical technique in which solving a problem often involves adding an extra dimension. In this case, stepping out of the linear dimension of time allows the possibility of jumping to another point in time, skipping intermediate moments. This concept is exemplified by the timeless nature of the photon. Since photons travel at the speed of light, they exist outside of time, where the temporal distinctions between moments become meaningless. From the photon's perspective, all moments, whether now or 10 minutes from now, are experienced simultaneously. This timeless nature of the photon allows it to transcend the normal time progression that governs large objects. Bohm's description of eternity within the now is perfectly compatible with this perspective. As he puts it, the deeper consciousness delves into the implicit order, the more similar these moments will be, and the less significant their differences will be. The deeper one goes into timelessness, the more indistinguishable temporal moments become, collapsing into a single infinite now. Bohm captures this dynamic between time and timelessness in a poetic metaphor. Now is the point at which eternity and time intersect. From this perspective, the now is both temporal and eternal. On its internal side, the now is identical to eternity, representing a timeless state in which all moments are one and interconnected. On its external side, the now participates in the movement of time and manifests itself as a series of distinct moments. This dual aspect of the now suggests that the time we experience is only one side of a deeper, more complex reality. In its external form, time flows and creates distinctions between past, present, and future. In its internal form, however, time becomes a timeless state of interconnectedness in which all moments coexist. Bohm's insight points to the possibility that consciousness itself can travel into this timeless inner infinity, allowing direct experience of temporal moments that lie outside the immediate now. The possibility of stepping into timelessness and coming into contact with temporal moments outside the present raises profound questions about the nature of consciousness, perception, and causality. If consciousness could somehow transcend the flow of time and enter a timeless state, it would be able to access moments throughout the entire timeline of existence, unconstrained by the linear progression of time. This concept is consistent with speculative ideas in quantum mechanics and cosmology about the non-locality of time, where events, even when separated by vast distances or epochs, can still be connected through deeper, timeless principles. If timelessness allows access to any moment in time, does this mean that causality itself is an emergent feature of our time-bound experience? What we perceive as causality in time may be a superficial feature of a deeper, timeless order in which cause and effect collapse into a single, interconnected whole. In the quantum realm, time becomes uncertain, allowing for the possibility of events flowing backward. Classical constraints, such as the second law of thermodynamics, may not apply to quantum systems. In these systems, quantum information can flow backward in time. In this framework, each conscious moment emerges as a now moment of objective reduction that includes quantum information from both the past and the future. A profound consequence of this theory is that quantum state reductions can include quantum information from the future, effectively introducing a hidden variable that accounts for the uncertainty of quantum systems. The idea here is that the uncertainty we observe in quantum mechanics may arise from our lack of access to relevant future information. The exact state of a quantum system cannot be determined until we develop a method to access that future information. Until then, the apparent randomness of quantum systems remains, but it may be governed by future quantum states. This idea is reflected in certain phenomena observed in everyday life, such as premonitions or prophecies, where individuals claim to have access to future information. However, these future insights usually come in the form of archetypal patterns. The fact that such future information is often vague or symbolic suggests that there is a limit to how we can access future quantum information, which is constrained by probabilistic factors inherent in the quantum world. If consciousness can interact with timelessness, it could provide a way for the mind to project itself outside of time. This would give consciousness a unique ability to access both past and future information, and would offer a possible mechanism for premonitions, intuitions, and other phenomena in which individuals receive information from beyond the present moment. The idea of subtle causality, in which quantum information from the future influences the present, suggests that consciousness is not limited to the linear progression of time. Instead, consciousness may operate in a multi-dimensional temporal framework in which information from past and future moments is continually incorporated into the now. This quantum temporal interaction may underlie consciousness's unique abilities, allowing consciousness to perceive beyond the immediate present moment and interact with the timeless order of reality. Experiments demonstrating predictive physiological responses provide support for this theory and support the hypothesis that the mind may operate within a timeless quantum framework. The discovery of quantum entanglement and closed time-like loops expands our understanding that causality may be more flexible than previously thought. This opens up new possibilities for how we think about time, causality, and the nature of consciousness, challenges the classical view of a strictly linear temporal order, and suggests that our minds may have the ability to reach beyond the boundaries of time. Thanks for listening, and take care.